I've been doing some experiments to see which method of making a transparency works best for printed circuit boards. So I've printed out 4 versions of this. This is actually just printed in this backing sheet. One has been printed onto film with a dye-based ink on an Epson printer. One has used a pigment-based ink on an Epson printer. One has used toner from an old Hewlett-Packard LaserJet 6L printer, and the other one has used toner but on tracing paper because it can do that, and that's what I used to use quite a lot. And to develop this, just for fun, I'm going to use this unit here. It's the ultraviolet nail varnish drying unit, which has a timer, and I've got it on at the moment just to keep it warm and so it provides consistent results. So I've just turned that off, and I'm going to lay these onto a piece of laminate and then put a big bit of glass over them. So let's get the laminate. Here we are, the photosensitive laminate. This is always quite hard to get the protective film off. This is basically copper-clad circuit board that has a light-sensitive film on it. And where it's exposed to the ultraviolet light, it weakens it. And then when you expose it using a suitable chemical, it comes off and it leaves a sort of etch-resistant coating. Here we go. So it's starting to peel. So there's the light-sensitive surface, he said, carefully angling it away from the lights. It's not super sensitive to the LED type light, but I don't want to just hang about here. So what I'm going to do is I'm going to place it down, and I can already see that I've just splattered on it. Ugh. Okay, right here. It's an experimental bit anyway. So I'm going to put the dye one here. Oh, actually, I'm going to put it face down. Then the pigment. Pigment does kind of look lighter than the dye one. Not 100% sure though. Toner, which looks even lighter. Yeah, I've been using toner for a while. Oh, is this all going to fit in? I'm not sure this is all going to fit in. Oh, it's not all going to fit in. So I'll just overlap this at the bottom. It doesn't really, I'm not really too bothered. It's just a test. So I'm just going to put this on like this. And then I'm going to put a piece of glass over that. This is glass from one of the clip photo frames where it just clips onto a bit of wood. And the reason I'm using this glass is because it's the right size for that circuit board material. And it's also got rounded edges, which is nice. So I'm going to use that to hold all the artwork down. And I'm going to place the ultraviolet unit over it. Messing everything up here, haven't I? Yes, I am. Just a little bit. Oh, yeah, really, I'm messing things up. That looks alright. And then I'll place the unit over. This is the open bottom unit, so I'm just going to place it over. And I have to say, it's not really going to be ideal. I wonder if I can do this sideways. That will possibly work better. No, I'm not happy with that. This is experimental, so I'm just going to continue anyway. I'll try the toner one on its own separately. I just want to get a rough idea of how this is going to work. And press the button. And the unit is now exposing with ultraviolet light, and it's going to take about 2 minutes. So I'm going to get the other chemicals ready for developing this, and I'll show you what they are. The safe chemical for developing, you can use sodium hydroxide, I think it is, drain cleaner, but it's really not predictable. The best one is something called sodium metasilicate, which is also called water glass. And this works as a very consistent developer. It develops slow enough that you're going to get predictable results each time. It also stays very stable. The sodium hydroxide solution, you have to make it up as you need it, and it is super critical. You have to have the water at the right temperature and the right quantities. And the ratio that you want in water of this is, let's see, what am I using at the moment? Where's my developer container? I'm using 12 grams in 250 millilitres of water at the moment. So using 12 grams of this chemical in 250 millilitres of water, which is quarter of a litre. So this is just progressing, it's just exposing now. I just thought I'd use this for novelty, this unit here. I do have a tubes and lid ultraviolet exposure unit, which I've used in the past very successfully, making tons of circuit boards. But I thought for the sake of this one, if you want an ultraviolet exposure unit, this one does work quite well. But yeah, again, you might have to not use it in automatic mode, you might have to use it in manual mode. The automatic mode is roughly about 2 minutes. Which is okay actually, it's pretty close to the correct exposure time, but again that depends on the light intensity, your material and your transparencies. It's all depend each other. So the unit is just turned off, so I'm going to get a glove on, a rubber glove, because the developer chemicals and the etching chemicals aren't actually particularly nice to hands, particularly the caustic soda one. I'm not sure what sodium metasilicate's like, the water glass, but I'm not going to give it a go. I'm not going to stick my bare hands in it because they do tend to be quite alkaline and caustic. So I'm going to put this unit out of the way. And when I take the transparencies off, you should see a slight outline of the image left on the laminate. And just visually by eye, I think the dye one might be the darkest. Okay, so I'm just going to put this down like this. I'm going to put some paper towel on here because I don't want to make too much of a mess on my bench. Bring up my printed circuit board developer solution. Hopefully my circuit board's going to fit in this. I usually just cut it into smaller pieces first. But let's give it a go. And here we go. So you have to agitate it under the water, and gradually the coating on the circuit board, the photoresist coating, will come off. Now I do notice it's coming off a lot faster at that end. Maybe it's going to be too fast at that end. It may actually be there's a hot spot of light, the ultraviolet light at that end of the unit. Also, I've used 4 different exposure materials here. You would not normally do that. You'd normally only use one exposure material because they may all have different speeds. And at the point this one, it's the point that would really have been close to stopping because it has almost fully developed. Not sure if you can see that. The slowest to develop are the ones at this end. I mean, they're film, they're the same film as the others, so I'm guessing the output of that ultraviolet unit is not very consistent. But that isn't really surprising given its design with the tubes quite close to the material. Okay, that's almost there. I have to get every bit off because if you leave any of the resist on the circuit board at all, it will stop the ferric chloride from being able to etch that. Okay, so far toner is the one that's coming out worst. So I'm going to plunge that straight into water. And the reason I'm plunging it straight into water is to stop the development process because I don't want to overdevelop. Okay. And the results so far are now was that dye the second one or pigment? I'm going to have to actually look back at the video and see and then make a note of which was which. This one looks the best so far. The toner one is eating away, it's not very good, although it's not too bad at this end on the printed circuit board, on the tracing paper, it actually looks pretty good. But this one so far is my favourite, so I'm just going to etch this in ferric chloride. So I shall get the ferric chloride system through. gathering dust. So this is a system called GS Etch, and it contains ferric chloride, and it's in a sealed plastic tube with these sort of spacers and grips. So what you do is you basically put the circuit board into it, like this, and it's sealed. It's a very clean system. Then you take a little black plastic rod, you fold it over, and you slip this on, and it grips it and makes a watertight seal. Then you pull this one away, and that unleashes the ferric chloride onto the circuit board, and it immediately discolours. It immediately goes a sort of dark brown. This is the point you'll see where you might have left some resist on, because the copper will stay shiny at that point, but it all looks okay so far. So this will take a wee while. It takes a good several minutes to actually etch properly, particularly when it's stone cold like this stuff is. So I'm going to pause the video and then I'll come back shortly. Okay, I've been sugaring this around for a while now, and it's now pretty much etched all the copper off where it's not wanted. So now I'm going to transfer the circuit board. I'm going to shake it up to the other end, if I can, grip it, drain as much of the ferric chloride down as possible because I don't want to waste any. Fold the little black rod, fold the bag around the black rod, isolate the ferric chloride in the bottom, and then I'm going to go to the sink and I'm going to open the top bag and fill it with water to rinse this circuit board. So I'll be back shortly. Okay, that's it rinsed now. No contact with the chemicals at all. It's a great system, this. And looking at the results, the most solid looking is the one that was based on the pigment. The dye-based one is not too bad at all. In fact, given how fast it developed, I wonder if that affected it. The one that looks the most solid though is the toner, not toner, is the pigment dye. This one just didn't work. The toner on the film just was a disaster. It's not exposed properly. The tracing paper one, which is just at the edge, not really been under proper ultraviolet exposure, doesn't look too bad. It looks pretty good. I think if it was down more central, I think with those circuit board, those nail varnish drying things, you'd be better restricting yourself to a smaller sort of circuit board area, maybe just 3 or 4 inches. But this isn't too bad. This is quite impressive. So, yeah, that is quite acceptable. I'm going to take a look at that under the microscope and assess just how well it's developed and etched. Okay, so looking through the microscope, the one with the dye, which again it may have been its position in the unit, because it did seem to expose quite quickly. It's slightly pitted, but it's really not bad. It's still perfectly usable circuit board. The one with the pigment ink is pretty much rock solid. That is really quite impressive. That is really quite impressive indeed. Yep, a very few pits in that. It's very good. Looking down at the toner one on the tracing paper, it's not a good representation, but I'm going to take a look at it anyway. And it's pretty solid too. Yep, okay. So now, let's discuss what I had to do to develop these, because it turned out not as simple as just printing from the printed circuit board package onto the transparency film. Now, the transparency film I used, I've tried various ones, and the one that worked best is just generic, universal transparency film. It's compatible with inkjet printers and laser printers, and it came from eBay. It was actually quite surprisingly cheap. I was quite surprised just how little it cost, and it provides very good results. But when you're printing it, if you just print with the inkjet printer, you think you're getting black, it looks like black, but you're actually getting a greyish colour because the inkjet printer tries to photo correct it for you. It tries to make it this, it tries to create the black out of cyan, magenta, yellow and black. It tries to be subtle and sophisticated about it, and that's just not what you want. You want just thick jet black. So I'm going to go and get some stuff printed off the computer, and I'm going to show you what I had to do to make the Epson printers do that. So after a brief break when I was printing these documents off, I've come back to this. I've cleaned it all off with acetone, and I have to say the pigment printed one, the one that used pigment inkjet ink, is absolutely superb. It's one of the best finishes I've seen on a etched circuit board in that style, and it's really promising. I'm going to be doing a lot more experiments. Now, I'm not going to rule out the dye-based ink, because the dye-based ink is much more common in printers. That I had to give the Epson a real hiding with replaceable, with refillable ink cartridges and pigment ink that it just, you know, it didn't accept it willingly, but it's got it now. The dye ink though, you get various types of dye ink, you get various qualities, some that just fade in the sunshine and others that hold their colour. And the ones that advertise as being high quality dye inks with ultraviolet inhibitors for preserving the colour, they might work better, they might be equivalent to the pigment ink. But at the moment I think the pigments won because the actual physical particles of ink in pigment ink have blocked the light much better. Now, making the printer, a typical Epson printer, this is an S22 I used. It was just a cheap printer that I got, actually bundled in with a laptop, and it's usable. And the only reason I'm using these printers is because my old Canon, my trusty refillable Canon Pixma IP4000, it burnt out its head, and oh god, it saved so much money in ink, that printer. It was so easy to refill. So I'm stuck with Epsons now, which are just not easy to refill. In fact, they're bitches to refill, but that's okay. Yeah, there are ways around that. But the main thing is getting onto using an Epson printer to print out black artwork. If you go from your printed circuit board package, like I use Sprint Layout, and if I just go and print out, the black doesn't come out black, because no matter if you select photo and you select a photo quality paper, purely with the intent of putting as much ink down as possible, the Epson will try and print it as a colour black, as in like a photo black, and it'll adjust it and be all fancy about it, and you don't get black, you get grey. And if you look at it through the microscope, it's not black, it's little dots of cyan, magenta, yellow and black. It's been a bit too arty-farty about it. But there are ways around this. There are ways to force that printer to print solid layers of black ink, and here's how you do it. You go into the printer preferences and you select photo, and that means it's going to put down a lot of ink. You select Epson Matte, and that paper is probably the one that absorbs the most ink, so that's the one that they'll put the most ink out onto. So these two will set the amount of ink. Now at this point you could choose grayscale. Now I ticked print preview, and basically speaking, before printing it comes up with what it's going to look like on the screen. It's not needed, but I did it. You can choose grayscale, but I found that, I'll show you the settings for it, but I found that when I printed it out in the same style using grayscale, which is just black and white settings, it actually still came out a darker black in the colour mode. So once you've chosen, I wouldn't bother ticking grayscale. I mean, you can experiment yourself. Once you've done that, go on to the Advanced tab. And when you go to the Advanced tab, in this case I was doing it with the colour settings. Colour controls, Epson Vivid is the standard. I left edge smoothing enabled, and obviously that I've already set the Epson Matte in the photo mode. But from that you can then adjust the colour mode. So choose settings, and when you do that you'll get this page, and no subtlety. Check slide bar and just brightness, contrast, saturation, cyan, magenta, yellow, right up to the max, plus 25, absolute to the hilt, and you'll see it gives you a little representation of what the image is going to look like, and it looks terrible. Good. it shows super black blacks and super white whites, and that's really what you want. It's going to extremely contrast. And likewise, you can do the same if you choose the grayscale, but it's only got a few settings, brightness and contrast. Not sure 100% the gamma, I didn't play around with that, but either way, when I did print it out, I found that with these settings, I got a blacker print than these settings. But when you're done with those, you can then go to shortcut section. You can actually save your settings. I'm trying to remember if there's another place you can actually set. Oh yes, it's from the advanced. You can choose save settings, and it'll take you to this page, and it lets you name it as a sort of like a colour image. So I chose the word blackest to name it and saved it as a sort of preset. And that means that when you go to print again, you go into the printer, you go to shortcuts, click blackest, and that's it. It will then print them in black. It won't remember it itself. You have to actually tell it when you go to print the circuit board, because you don't want to permanently set that extreme set of range of colours into your printer. It's good that when you just go to the printed circuit board package, you then select that for the black image, for the transparencies. So that's how it happens. And yeah, I'm going to play about more. I've got other experiments on the go with this. But so far the pigment is very impressive, very nice indeed. Good result, especially the fact it was done with something as simple and cheap as the ultraviolet nail varnish setting unit. Because normally I'd use my tubes in lid ultraviolet industrial unit, which cost an absolute fortune. And although it can cover a much larger area, it's nice that for small circuit boards you can use that unit and it's just a one button press and it does its 2-minute cycle and that's it. It's a good result altogether. So yes, very good result. Better than I was expecting actually. Really impressed the pigment ink. Oh, I just thought of another important detail. Epson printers, when you feed paper through them, they use a light sensor at the side. And it doesn't matter the size of paper because gradually, progressively, the different sizes move towards the right hand side. And it uses an infrared or other light, I think it's an infrared sensor with it, and it sees the paper passing through it. It doesn't see this film passing through it, and it will just spit it right through the printer. It will treat it as an error, it will feed it out, and then it will just feed in whatever was behind it. So you have to cheat. You have to use a bit of A4 paper and fold the bottom, and you can keep reusing this. And basically speaking, you're going to just sit your film down into that, and the bottom, because it's folded, will pinch it and it will grip it and pull it through. And then you just load that in your printer as normal, and when it goes down, it'll see the paper, it'll block the infrared beam, and it'll print on it as normal. So that's something you have to do with that. Also, it's worth noting that these films have one side that you can print on. If you rub it, you can feel one side is slightly matte and the other side is sort of shiny. And the other way you can test is go to corner, lick your fingers, just press them on it, and the side your fingers stick to is the side it's going to print on, because that's going to absorb the ink. So that's a useful little extra bit of information that would cause problems. It certainly caused me a bit of consternation and lots of trying to fix it with different ways, and this by far is just the easiest, just the ordinary sheet of paper with the edge folded. Is this video ever going to end? Because I keep thinking of things that I can add to it. While I was buying loads of the different transparencies, I thought, there's Staedtler, really big name, that should be a really good paper. And better still, it comes with the backing sheet on it so that the printer can see it. This paper did not work with the Epson ink. It was rubbish. What actually happened when you looked at the printout, it had pulled up. It had little streaks and lines and dots missing. It just did not soak into this paper properly. So that's also worth noting, that if you're going to try printing transparencies, it's worth, right from the start, get a selection of different ones to try before you commit yourself to, don't just assume that you can get a high profile brand one that's going to just be the only one you need. It's worth trying a few different types.